Hello everyone, in this video we will talk about introduction to stack in data structures. As discussed in previous video, we are living in a world where applications are generating lots of data every day, like social media websites, Facebook, Twitter. They are generating lots of data in terms of petabytes every day, and it has become a huge task to manage that data in a more effective and efficient way. Data is being a big challenge these days. So what are the questions that arises in our mind, that how to use the data, how to store the data, how to process the data, and how to gain knowledge from it, and how to keep this secret. So data structures deals with the second and third question, which discussed how to store the data and how to process the data in a more effective way, such that the time taken by the algorithms which are running will be minimum. So go ahead. So if we see the classification of data structure, they are categorized into two parts: linear and non-linear data structure. In linear data structure, we have array, linked list, stack, and queue, while in non-linear segment we have tree and graph data structures. We also can give the term elementary data structure to data structure like array, which is shown in the lighter blue blocks. That's the array, which is basically the set of similar type of elements which are stored in a continuous memory location. We call it array. List, basically representing the linked list part. On the right hand side there is the linked list shown here. This is just an example, that the head node, which is the starting node of the linked list, and this is the linked list. Then there is a stack. So this diagram represents stack, although we are going to discuss that in some couple of minutes. Queue, like a normal queue, it's a very important data structure too. And then tree, and that looks like these arrows and nodes. It's a collection of nodes connected with edges. That's a tree. We'll discuss tree in later stage. So these are some elementary data structures which are predominantly available in many programming languages. They are pre-declared in some programming language, while in other languages we may need to declare them explicitly. So what is basically a stack is? So a stack is a list of elements where insertion and deletions are allowed only at one end. It means you can only insert the element at one end, and you need to delete the elements from the same end. That end is termed as top. That's the index. We call that top. Top is the terminology which is popularly being used with a stack. This is the name given. Top is the index point, which refers the insertion and deletion location of data into the stack. Therefore, we can say stack is based upon the concept of LIFO, that is last in, first out. You can see in this beautiful colorful bricks diagram. Here we can see a blue brick is being inserted on the top of the yellow brick, and when we call deletion operation, that blue brick is removed from the top location. And after that, if we continue this deletion process, the next brick which is to be deleted will be the yellow one. Instead, the insertion operation is termed as push, while deletion operation is termed as pop. That is why push and pop operations and the term are being written here with this diagram. So summarizingly, a stack allows you to insert and delete elements from only one end, which we call top. That's why it is based upon the concept of LIFO, last in, first out. The insertion operation is called push, while deletion is called pop. So you might be wondering, why do we need this kind of mechanism where you're inserting data from one end and deleting from the same end? Do we need that? So intuitively, if you see, or you just try to visualize this in your mind, you will feel this thing, that the data which has come in the later part will be removed first, and the data which has come earlier, or you can say in the very beginning of this operation, that data will be removed in the later stage. So where do we need this kind of mechanism? So if we see a popular web browsers, which we are using these days in one or another way. So web browser, if you can see, there is the if you are working on a web browser and you just click onto the back button, you just go onto the back page. If you click again onto the back page, you will go onto the back page you have served. So this is a kind of hierarchy that is maintained in web browser, so which is popularly used stack to implement this hierarchy. There is one more term, which is the undo sequence in a text editor. You must be using text editor for many tasks, so just try to remember. If you undo, what it does, so you just do one thing, you just write five words and just start doing this undo operations, then you will realize whatever you have written in the end will be undone first. So similarly, saving of local variables while doing function calls, recursion, these stack operations are heavily used. We will see many more other applications of stack in upcoming videos. So here this diagram also represent stack where push and pop operations are being shown on the top of the stack. So what are the various operations possible in stack? So you can create stack, that's a create operation. You can push basically the insertion of the elements at the top element, at the top pointer, while pop removes and return the top element. So remember here, the pop not only removes the element but also return the element which has been removed, okay, to the calling function. Top operation here returns the top element, while is empty operation tells you about whether the stack is empty or not. So here I just want to mention that stack normally are having a fixed size, so it cannot absorb element more than its capacity. So when stack is full, you cannot insert element, and at that point of time your stack will return some kind of error or exception that the elements cannot be inserted, stack is already full. While if you're trying to delete elements from the stack and there are no elements in the stack, elements are already deleted, then this is empty function will tell you that the stack which you are trying to use is already empty. So these are some popular stack operations, and here this is just an example that says if you are that says there's the stack of integer elements and you are pushing some elements. If you are pushing 8 3, it means these elements are pushed onto the stack. Now it's up to you. Now it's a quick exercise for you. If we call pop now, what element will be popped? Will it be 8 or will it be 3? So just think about this. Now yeah, you're right, this will be 3 because 3 which is inserted later, it is on to the top position, so this will be popped first. Similarly, now you are pushing 2 5 and now you are calling pop function 2 times. Now you need to tell us, come on, just try do this exercise by yourself. What are the elements which will be popped? And you just repeat this exercise. So this is just a simple introduction video of stack. In the upcoming video we will see about the push and pop operations, the algorithms we will see about of the push and pop operations, and then we will see what are the various use cases of stack where we can use stack. Thanks for watching this video.